Module 9, Acid-Base Chemistry, the behavior of ionic compounds in aqueous solutions. Let's talk a bit more about how ionic compounds behave. You learned that an ionic compound conducts electricity when it is dissolved in water. Well, we can now talk about how that happens. In order for a substance to conduct electricity, it has to have electrical charges which can move around. H2O, or pure water, is a polar covalent compound. It has electrical charges within the molecule, but they cannot move around freely. They have to stay within the molecule. Yet, because of the differences in electronegativity of the oxygen and hydrogens, a water molecule has a slightly negative side and slightly positive sides. It is a polar molecule with covalent bonds. All the charges are held together within the molecule. Now, when an ionic molecule dissolves in water, such as sodium chloride, things begin to change. Ionic compounds will split up into their individual ions. This is an important point, so I'm going to repeat it. When ionic compounds dissolve, they split into their constituent ions. So when it is dissolved into water, sodium chloride will split up into sodium ions and chloride ions. These charged ions can move about the water freely. That means they can conduct electricity. Now let's talk about why acids are covalent compounds that can conduct electricity when they are dissolved in water. Here is the first acid-base reaction we looked at in this module. Two ions were produced, a hydronium ion and a chloride ion. Once they are formed, these charged ions are free to move around the solution, so that solution can conduct electricity. They behave just like ionic compounds in water.